In this video, we will review how to solve right triangles. We will pay special attention to sine, cosine, and tangent. Know these definitions. If you are looking at an angle in a right triangle, first of all, the hypotenuse is across from the 90-degree angle. Now, across from the angle you're looking at is called the opposite leg. Right next to the angle you're looking at is called the adjacent leg. Now, armed with those words, you can define sine, cosine, and tangent of the angle. Sine of the angle will be the opposite leg over the hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, to make it easier to remember, we will sometimes say, just use SOHCAHTOA. And of course, that is the three definitions squeezed into one funny sounding word, where SO stands for sine is opposite over hypotenuse, CA, that's cosine, is adjacent over hypotenuse, and TOA, tangent, is opposite over adjacent. So if you can remember SOHCAHTOA, then you can remember all of your definitions. Okay, Gene's eye level is 1.5 meters off the ground. When he stands 440 meters from the base of the Eiffel Tower, he must tilt his head up by a 36-degree angle. All right, that's the angle of elevation, to see the top of the tower. Based on this, how tall is the Eiffel Tower? Okay, so I'm going to put a big old X right here to represent that we are looking for the height of the Eiffel Tower. Okay, now be careful. The Eiffel Tower is not the side of the triangle that we have. See the 36? The Eiffel Tower goes past this side of the triangle. So we'll have to add an extra 1.5 to whatever we find. We're going to have to add an extra 1.5 to get the height of the Eiffel Tower. In fact, maybe I won't call this X. I'll save that for later. Okay, I'm going to call this X. Okay, let me just see if I can squeeze this in here somewhere. Okay, so looking at this side of the triangle right here that I'm coloring in green. All right, that's what I'm going to call X. Okay, X is this green side of the triangle. And of course, we're looking for the height of the tower. I'm not even going to make a variable for that. I'm just gonna put tower, and because that's what we're looking for. So first we'll find X in the usual way, but once we find it, we will have to add 1.5, an extra 1.5 to be the total height of the tower. So let us circle the angle that we have and label all the sides. Across from the 90-degree angle will be the hypotenuse. Across from the angle we circled is going to be the opposite leg. Right next to the angle we circled will be the adjacent leg. Okay, which of these sides is not doing anything? The hypotenuse is not doing anything. There's no number here, and there's no variable that we're looking for. If you look too quickly, you might think the adjacent leg is doing nothing. But the adjacent leg is 440 meters. Okay, so for that reason, when we start to think about SOHCAHTOA, okay, we had to throw out the useless hypotenuse. And sine involves hypotenuse, so we're going to throw that out. Cosine involves hypotenuse, so we're going to throw that out. So that just leaves tangent. So that's why we're going to do tangent of the angle we circled is equal to opposite over adjacent. That's X over 440. Alright, when the variable is in the numerator, that's when you multiply. Alright, calculator time. So this will be 440 tangent 36. Okay, so that's 319.679. Got to round up. Okay, now that's x. Now remember, the tower itself is an extra 1.5 meters. So I need to add an extra 1.5 to this, and that will be the tower. Okay, so that's 321.179. Okay, meters. Okay, a couple of review questions. Man, I was not emotionally prepared. Okay, but let's go ahead and do these review questions. So these questions have nothing to do with tangent, sine, cosine, any of that. So if you are watching this video because you wanted to learn about tangent, sine, and cosine, you can skip these last two problems. So we want to dilate by a scale factor of 1/3. But we have to dilate from the point 3, 3. That is the center of dilation. So let's find that point. So the point 3, 3 is right here. Alright, that's my center. So I'm going to do this by the arrow method. So basically, if I take this one variable at a time. Alright, so I'm going to do A, and then I'll do B, and then I'll do C. Okay, you know what, maybe I think I should probably write them horizontally. So here I have A, then I'll have B, and then I'll have C. Okay, so the path to point A, alright, from the center, I would have to go left 3. Okay, so I would have to do left 3. Okay, so if I want to get to the image, if I want to find the image of point A, I need to take that and multiply by the scale factor. Okay, so the scale factor is 1/3. So if I take this and I multiply by 1/3, okay, 3/1 times 1/3, that's 3/3. Okay, so that's going to be, okay, so that's going to be 1. So this is going to be left 1. So that's how I get to the image. It's not a very good one. Okay, left 1. Alright, so let's take a look. So instead of going left 3, I'm going to go left 1. And that should be A prime. Okay. Now let's do B. Okay, to get to point B, I would have to go left and then down. Okay, now I'll have to go back and count exactly how much left and down I went. So I had to go left and I had to go down. So let's see. So that was left 6 and down 6. Okay, that's how I got to point B. So I need to multiply that by the scale factor of 1/3. Okay, but 6 over 1 times 1 over 3, multiplying straight across, that's going to give me 6 over 3, which is 2. So in other words, I need to go left 2. Okay, and of course, if I did the same thing, since this is also 6, of course I'm going to get the same thing. So I need to go left 2 and down 2. Alright, so let's do that. Alright, so if I go left 2 and down 2, then that puts me right here. So that is going to be B prime. Alright, one more time. For point C, the path to point C from the center would be this. Okay, and so what just happened? I just went left 6. Alright, and we've already seen how this turns out. So I need to multiply by the scale factor. Alright, but we've already seen that 6 times 1/3 is 2. So that means I need to go left 2. So from the center, if I go left 1, 2, then that's going to put me right here. Okay, and that is going to be C prime. Alright, so I'm just going to draw this teeny tiny little triangle, if I can. Alright, and that is the image under this dilation by a factor of 1/3. Okay, number 18 is much easier. This is a translation. And adding 4 to the x value, that just means we're going to move to the right 4. And subtracting 2 from the y value, that just means we're going to move down 2. So we're just going to go right 4 and down 2. So I will just move all of the points right 4 and down 2. So if I move this right 4 and down 2, and if I move this right 4 and down 2, and if I move this right 4 and down 2, then this will be the image. Okay, and this will be A prime, B prime, and C prime. Okay, now the bonus will take us back into the world of tangent, sine, cosine, etc. Alright, find the length of x in this diagram. Okay, so we're going to have to do this in stages. If I want to find the length of x, I'm going to need one of these acute angles. Now this angle over here has nothing going on. This angle over here has a 22, alright, but it's missing this part right here that I will call theta. Okay, we're missing theta. If I could figure out what theta was, then I would add that together, and I could have this whole angle, and then I could go ahead and solve this triangle. Okay, so really it's sort of like this. Remember that on a previous problem we had two triangles stuck together, and the first thing we did is we split them apart. Alright, I tried to color code it a little bit so you can see the two triangles because they are overlapping. Alright, instead of being, I'm not looking at the two triangles that are side by side. I'm looking at the pink triangle that's inside of the purple triangle. Alright, so now I'm going to draw those separately. So here comes the pink triangle, looking all like this and stuff. Alright, so here's that 71, here's the theta that I'm going to need, and here's the 65. Okay, there's that triangle. So I'm going to solve this for theta in a minute. And now here is the purple triangle over here being all like this. Bam. Ba-bam. Okay, and this angle, there's my 90 degrees, there's the 65 again. This is the x that I'm actually looking for, and once I have the theta, I'll be able to know what this angle right here is. Alright, right now I don't know what this is, but I will know it after I solve for theta. So that's my strategy. Okay, let's start with this. You know, I should probably use a different color. So, like we do, let us circle the angle and label the sides. So this will be the hypotenuse all across from the 90 degrees. Across from the angle that you circled, wait, that's another angle, hold on. Hold on. In fact, what am I doing? What did I almost do? We don't need SOHCAHTOA to find this angle. Yeah, we don't need SOHCAHTOA to find this. I have another angle over here, so I can just subtract from 90. Alright, these two angles have to add up to 90. So I'm not going to use anybody's SOHCAHTOA. Alright, I'm just going to do 90 minus 71. Okay, so that's 19. So that tells me that this angle right here is 19. Okay, so looking back at the picture, alright, that's this angle right here, and I now know that this angle is 19. Okay, now if I put these two angles together, then that will tell me what this angle is. So that's going to be 41. Right? Because 19 plus 22 is 41. So now that I know this 41, now I can do my SOHCAHTOA, use my SOHCAHTOA skills. Okay? So SOHCAHTOA. Let us circle the angle that we've got and label the side. So this is the hypotenuse across from the angle that I circled. That's the opposite leg. Right next to the angle is the adjacent leg. Which of these is doing nothing? The opposite side is doing nothing. There's no number here, there's no variable that we are looking for. It is useless. So sine involves that useless opposite side, throw it out. Tangent involves the opposite side, throw it out. That leaves cosine. So we will do cosine of the angle we circled, and that should equal adjacent over hypotenuse. So that's going to be 65 over x. When the variable is in the denominator, you swap these. So that's going to give you x is equal to 65 over cosine 41. And that's something you can just put in your calculator. 65 over cosine 41. And that's going to be 86.126. Got to round up. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.